Hello, and welcome back to another IB Math Speedrun with me, Vince. In this speedrun, we're going to be going over Chapter 9.8, which is all about the application of vectors. So let's jump right in. So, when we're talking about the real-world applications of vectors, one of the fields that comes to mind is physics and kinematics, where we need to be able to distinguish between vector and scalar quantities. So, we need to remember that, it's a bit slow. We need to remember that displacement is a vector quantity. Oh, can't spell. Velocity is a vector quantity, and acceleration, is a vector quantity. And as well as this, remember that distance is a scalar quantity and speed is also a scalar. So remember that vector means that it has both a direction and a magnitude, just like we've covered in this chapter, and scalar means it only has a magnitude. And so with these vector quantities, often we're asked to find, like, say, we have velocity in this direction, express it in terms of unit components, or stuff like that. So let's do some questions involving those kinds of things. So the first question is, I'll do the odd ones. There is a boat on the sea that needs help. Two boats are nearby and they have received the call. If you place the boat in need at the origin of the coordinate plane, and the other two boats called Adrienne and Lily are at the points A, which is at -3 and 5, and B, which is at L, which is at 7 and 9. It's quite a long question. The coordinates are given in kilometers. They move directly towards the boat in need. Adrienne, I'll just use A, with a speed of 4 meters per second, and L with a speed of 6 meters per second. So first, find equations representing the courses of the two boats, and B, determine which boat will arrive first and how much longer it will take the other boat to arrive. Okay, so quite a long question. So first, we need to find equations representing the courses of the two boats. And we have that, okay, let's find the Adrienne first. So let's represent it with the vector A. And so this will be equal to, well, it's at -3,000, 5,000. So we can say this is at -3,000, 5,000. And with time t, in seconds, it will move with a speed of 4 meters per second towards the origin. So the question is, how do we find how fast it will move? So we know it will move in this sort of triangle with ratio of sides 3 to 5. So this will be 3x, 5x, and then we know this side is 4. So we have 16 squared is equal to 9 plus 25, 31x squared. So x squared is equal to 16 squared over 31. So x is equal to, just get x is equal to 4 over the square root of 31. Sorry, I mean 16 over the square root of 31. Oh, did I get it wrong? Wait. Negative 3, 5, 4. Oh, I might have miscalculated here. Sorry, why did I put 16 squared? It's only supposed to be 4 squared. It's equal to 25 plus 9. Oh, and this is 34. Oops. Anyways, 4 squared is equal to 34x squared, so x squared is equal to, x is more or less equal to 4 over square root of 34. So we can plug this in, so we have that it's moving horizontally at a speed of 12 over square root 34, since it's 3 times that, and vertically at a speed of 20 over square root 34. Actually, it's above the x-axis, so this will be negative. So this will be equal to 12 over square root 34, and then minus 20 over square root 34. So this is the vector equation for the movement of Adrienne. Next, for the movement of Lily, which we'll denote as L, this is equal to can't drag. Okay, it's at 7,000 and 9,000, and it will be moving with a vector. So this will be 7x, 9x, and this will be 6. So we have 6 over the square root of 7 squared plus 9 squared. So we have 6 over square root 130. And then in this case, for the length, it's times 7, and for the height, it's times 9. So we have 42, negative 42 over square root 130, and negative 6 times 9, 54, over square root 130 as the movement vector for this. Remember, it's negative because we're actually above the origin. If this is O, this is the point where the boat is at. This is the point L, and so we have to move backwards to get to the origin. Okay, so that's part A done. Next, determine which boat will arrive first. So we have over here, since we know it is going to intersect the origin, we can simply say that 3,000 is equal to 12 over square root 34t. We can only solve one of the parametric equations, and in this case, 7,000 is equal to 42 over square root 130t, and we need to calculate which t is lower. In this case, 3,000 times square root 34 divided by 12 is equal to 1,458 seconds. And 7,000 is 7,000 times square root 130 divided by 42 is equal to 1,900 seconds. So we get that Adrienne will be there at around 442 seconds faster, which is actually not a lot. These boats are quite fast. Just check that's correct. Oh, where are we? Oh, we're actually past that, okay. This is 9L. Uh, 9L. Yep, so boat A will arrive first. So that is correct. And then on to the final question, and that one is the radar controller Boris spotted 2 planes in the air. The computer is calculating paths of both planes, and these are found to be P1 is equal to 147 minus 8t times I plus minus 156 plus 9t times j plus 5 plus 0.25t times k. And then the second plane is equal to negative 118 plus 7t times I plus 189 minus 11t times j plus 7 plus 0.2t times k. So first find the speed of both planes. Next, find whether the two paths cross, and if yes, find the point of intersection. And C, determine whether the planes collide. Okay, so first find the speed of both planes. Well, we have that this plane here is really moving with a vector of -8, 9, and 0.25. So we can get the magnitude of this vector, which is equal to square root of 64 plus 81 plus 0.25, 0.62, no, wait, 0.25 squared, 0.0625. So this is equal to plus 64 plus 81, square root this, it's equal to around 12. I'm going to assume this is in meters per second, but they don't really give units. Okay, next, for this lower plane, this is equal to the magnitude of 7, negative 11, and 0.2, which is equal to the square root of 49 plus 121 plus 0.04, which is equal to 49 plus 121 plus 0.04. Square root that, it's around 13 meters per second. Okay, next, find whether the two paths cross, and if yes, find the point of intersection. So in this case, we just have to equate. Let's convert it into a parametric form first. So we have 147 minus 8, and let's say a constant called lambda is equal to negative 118 plus 7, and then let's say mu over here. Next, negative 156 plus 9. Lambda is equal to 5, is equal to 189 minus 11 mu. And then finally, 5 plus 0.25 lambda is equal to 7 plus 0.2 mu. So we have to try and solve these equations. So first, we can express lambda in terms of mu. So this top one means that lambda is equal to negative 118 minus 147. So negative 265 plus 7 mu over negative 8. So this is equal to 265 minus 7 mu over 8. So if we substitute it into here, we get negative 156 plus 9, or let's multiply everything by 8 so it's simpler. So we have 156 times 8, so we have negative 1248 plus 9 times 265, 2385, minus 7 times 9, which is minus 63 mu, is equal to 189 times 8, 1512, minus 11 times 8, minus 88 mu. So all in all, we have 88 minus 63, so 25 mu is equal to 1512 plus 1248 minus 2385. So 25 mu is equal to 375, so mu should be equal to divided by 25 is equal to 15, and so therefore lambda is equal to 265 minus 7 times 15 divided by 8. Lambda is equal to 20. And so we can just substitute this into the final equation to check if it's okay. 5 plus 0.25 times 20 is equal to 7 plus 0.2 to 15. So we have 5 plus 0.25 times 20. So we have 25 is equal to 7 plus 0.2 times 15. Oh, this is a bit odd. Oh, have I done this the wrong way around? No. So do the paths just not intersect? I think I didn't. 5 plus 0.25 times 20. Oh, sorry, this should be equal to 10. Because 0.25 times 20 is, yeah, I was like, why is this weird? 0.25 times 20 is 5, so this 10 equals 10. So the paths do intersect. However, do the planes collide? No, because if we look at their two variables, which we used to substitute for time, they intersect, the paths intersect when the points are at different times. So assuming that these points are starting when time equals 0, they will not intersect. So one plane will fly past the point at 15 seconds and the other plane will fly past the point at 20 seconds. So therefore, there will be no collision between the planes. So that was all for the speedrun. I hope you enjoyed and I hope to see you in the next one. See you then.